Hi folks, welcome back. We are talking about dynamics. We are doing a super fun problem. This is acceleration, and here is the physical system. We are looking at a two-bar linkage with a slider on one end and a cranking mechanism on the other. The short AB section is rotating at a rate of 8 radians per second. It's accelerating at 12 radians per second squared. It is in the position shown, and we are asked to find the V and A component of the motion of point C. So let's get to it. I brought with me a reminder that the acceleration about a fixed axis is the a sub t plus a sub n, and those relationships are given here. We're going to need that because we need to calculate the v component at b and the a component at b. So to begin with, if we look at the bar AB, so this is A, this is B, then there's a V component and then an A component like this. Okay, so this is AB, VB, and we should see if we can calculate those. So first things first, we need the vector from A to B, right? So let's call this AB. Okay, and the overall length here is 0.25. Okay, so this is at a 45-degree angle. So what do we need? We need 1/4. So AB is going to be equal to, do shorthand here, so minus 1/4 sine square, or sine of 45, I minus 1/4 cosine 45j, and let me calculate those real quick because I think it'll save a bit of writing. So 0.25 sine of 45, what's that give us? That gives us 0.177. It's actually 1768, I guess. So we'll just add it here. So AB equals minus 1768 I minus 0.1768 J. Okay. Awesome. And let's see, so VB is equal to omega cross R, right? And we can get there in two ways, and we'll do both, right? We can do the component method or just the absolute value of it, right? So the let's see, this is also omega R, right? So this is scalar, this is vector. In the vector, this would be omega k, so what is that, 8k crossed with these values, right? So minus 0.1768 I minus 0.1768 J. Okay, and so that means that VB, and let me put it over here, VB is going to be equal to either 1/4 times 8, which is 2. So either 2 meters per second. And also, so let's see, 8 times this guy that we just calculated is 1.4142, and so k cross j. K cross j is negative I, and negative, it's already a negative, so it's positive, so this is going to equal 1.4142 I, and then k cross I is positive j, so positive, but there's a negative, so minus 1.4142 j. So this is our VB. I guess I was going to put it over here, so be consistent, 142 I minus 4142 j. Okay, awesome. So now, do we have enough to get to that? We have omega. Yes, we do. So let's go ahead and calculate a sub b while we're here. A sub b is alpha, and that's in the k direction, cross r, but this is ab minus omega squared ab. Okay, so alpha we're given as 12, so 12 k crossed with this, and I'm just going to write it out because it's I'm writing a bunch of repeat values, so 12 times 1.4142, so times, okay, so this part equals 16.97, it says 06, so we'll just go with 9701, or excuse me, 971, so 16.971, and so this is k crossed with I, and k crossed with I is j, so let's do the j first, so k crossed with minus, wait, that is not what we're crossing at all, it's the a. So this is AB, they're both negative, so k cross j is negative, so positive times a negative is a positive, so 16 there, so that's I, and then we found last time that it's minus 16.971 j, and then minus, and we have omega squared, which is 64, times these, so what do we got, 64 times 1.41, wait, not that, this, times 0.1768. And we get 11.3152. So minus 64 times this gives us 11.3152. So minus times a minus is a plus. And actually they're both going to be plus. So 11.3152 I plus 11.3152 j. Right, so we have in the I direction 16 plus this. Is that right? These numbers seem high. A is, yeah, let's recalculate this. So this is not squared. This is A times this. And that is, what did I do there? Oh, I see what I did. Okay, so that is not that. That's 12 times 0.1768. I keep trying to calculate the wrong thing. There we go. That is 2.122. So these values, and it's 2.1216. So 2.1216, 2.1216. There we go. All right. finally in business. Okay, so here, a sub b, and now I'm going to put it over here. A sub b is equal to this plus this, so plus 11.3152, 11.3152, 13.437. So 13.437i, and then it's essentially 11.3152 minus that. So let's see. That guy. 2. Hold, please. There we go. 9.194. So plus 9.194, and that's in the J direction. Okay, sweet. All right, so that allows us now, that gives us inputs for both the V sub c and A sub c. Okay, so now we can draw the free body diagram of CB. What does that look like? That looks like that sort of, a little more of an angle, right? Because it's 60 degrees from the horizontal. All right, and so let's see, this is V sub c goes this way. And V sub b, let's see there, so it's going that way. A little bit off. VB, okay, so we want the point of instantaneous rotation. Okay, so it's going to be down here somewhere. And then this comes off normal to that. That there. Awesome. We'll call this point D. We can call it whatever, but D works. Alright, this is 60 degrees here. And this is vertical because V sub c is horizontal, so this is 30. Alright, if this is 60, then this is also 60 here. And this comes off of the horizontal, right? So this is 45 here. And if this is 45, then this is 45. So 45 plus 60 is 105. So 105 degrees. And 105 plus 30 is 135, making this a 45 degree angle. Okay. So now we know the length of this is 0.5. Okay. So we can use this. Let's see, this is B right here. This is C. And we can use the law of sines to calculate the lengths of these vectors. And I say that we use, we switch over and use a different color because too much black. All right, so let's see. CD is equal to, or excuse me, CD over the sine of the opposite is 105 is equal to 0.5 over the sine of 45 is equal to BD over the sine of 30. Okay, all right. So we can crank these out, right? CD. So this is going to be going from C to D, so it should be a negative J direction, right? And what is that going to be? Let's see. That is 0.5, 0.5 times the sine of 105 divided by the sine of 45. And is it right? Hold on. That looks better. Okay, so that is 0.683. And what are we doing, blue here? Okay, so this is equal to minus 0.683 683 in the j direction. Then BD is equal to, and let's see, I believe that we just need, for this one, we just need the magnitude of this. So what we can do is just BD, yeah, so let's see. 0.5 times the sine of 30 over the sine of 45. That looks to me like I just have to change one number in the calculator. Okay, and that is 0.3536. So 0.3536, that is our bulk direction. And if we wanted that in components, which I can't remember if we need or not, but that's going to be minus 0. So this times the sine of 45, but check it out. If we just think about where we were, then it was BD times 0.5 times the sine of 30 divided by sine of 45. So if we multiply it times 45, then it's just 0.5 times 0.5, which is 0.25, right? And both of these are going in the negative direction, right? So negative I, negative j. So it's minus 1/4 I minus 1/4 j, right? And those are our vectors. So now what we're going to try to do is we're going to try to get v sub c based on this v sub b that we already know, right? We already have it here. Okay, so from v sub b is equal to omega, and I'm just going to call it omega here, cross r. But I have r, right? So that's BD, and I have omega as a value, or not, I'm sorry, not omega, but VB is right there. So this is r, because we just need the scalar. We know what direction it's going to turn in. And so that implies that omega is VB over r, and in this case r is BD. Is that right? No, we need to cross there, right? So this is actually dB, and because we're looking, well, I guess it doesn't really matter. We can go either way. That direction, cross there, that gets us rotating in this direction. Right. It doesn't matter. We can work it out in a second. So BD. And what is that? That is 2 divided by that. So 2 divided by that guy gives us 5.657, 6568, I guess. So we have omega equals 5 point, we'll say 657. And since we're going to need the omega squared right there, let's calculate that. Omega squared is equal to, square that bad boy, and interestingly enough, that gives us 32. Omega equals 32. My calculator says it's on the nose, so that is kind of a super fun thing. All right, so we have that. Now we should be able to get to, let's see, let's go back to black here. We're going to try to get to v sub c. So v sub c is equal to omega, and then this will be CD. So cross CD, and let's see, these are orthogonal to each other, so we can actually just use the scalar. And what is this? This is 5.65 0.657 times 0.683, 0.683, and we get 3.864. Going in that direction, say meters per second. Going in that direction. So that confirms it actually. We should have used D2C, right? So that would actually be pointing the position vector. That's the way I usually remember it, is that we're pointing the position vector toward the velocity vector. And here we're pointing that in that direction, and yeah, because they are normal to each other. Okay, so we have that. So let's put this over here. I think we're going to need a little more room just to bust out this last part of it. Maybe not. We'll try it. I think we can get there. So what are we after? We're after a sub c, that is equal to a sub b plus the normal and tangential components, right? So plus alpha cross r, and in this case we're talking about CB. So alpha cross CB. Not sure if we need that one or the other, but let's just go with CB. Okay, and it is CB. And then minus omega squared, and then CB. Actually, it's BC. Right, because we're calculating the acceleration of that. BC. Sweet. Okay, so what is BC? BC is from B to C, so BC is equal to 0.5, and this is minus 0.5 times the cosine of 60i plus 0.5 times the sine of 60j, and let's see, 0.5 cosine 60, I believe we're just going to end up back at 0.25, right? So this is equal to minus 0.25i plus, and I'm almost positive that's 0.433. Can tell you that sort of indicates how many times I've attempted this problem, right? Let's see, so 0.433j, okay, and that is our BC here. So alpha, we don't know. This is K. A sub C, something to notice is that this can only accelerate in the I direction, right? So this is limited, and so we can rewrite this as A C I is equal to, and then A sub B is, where do we write it? We wrote it right here, this guy here. So this is equal to 13.437 I plus 9.194 J plus, okay, alpha, we don't know, right? So alpha, K, this is alpha in the K direction, crossed with BC. So this, we don't know yet. So what I'm going to do is I'm just going to write these in. So alpha K, we'll make a little space here, alpha K crossed with BC is alpha K crossed with J, KJ is negative, so minus alpha J, so 0.433, so minus 0.433 alpha in the I direction, then minus ki is keeps its sign, so minus 0.25 alpha in the j direction, and then we've got minus omega squared BC, so minus omega squared times BC, okay, and omega squared is 32, so 32 times 0.25 is 8. Alright, so minus times a minus is a plus 8i, and then minus times positive is negative. I feel like I'm telling you things you already know. So this is minus 13.856. And that's a J. Okay, so keeping in mind that this acceleration can only happen in the I direction, that means that we can solve the J direction for this alpha, so that we can then figure out what the because the J component is not going to add to the output answer, right? So let's solve the J direction up here. Okay, J direction, and so we got 0 equals, then J, I'm just going to tally these up. I'm going to say 9.194. This is alpha, so minus 13.856, so this is minus 4.662, and then the J here is minus 0, well, I guess it's 1/4, right? 1/4 alpha. Okay, so from here we just add 4.662 to both sides and then multiply it times 4, and so alpha is equal to minus 4 times this, so times 4 is minus 18.648, and so that's going to be radians per second squared, and that is the rotational velocity or excuse me, the rotational acceleration of bar BC. And there, 0.25, so divided by 0.25, yeah, that is the value. Just want to verify that my thinking on this makes sense. Okay, yeah. Thought it would be a little bit lower. Okay, all right, so finishing this up, we can solve now in the x direction, right? So in the I direction. So AC is this. So what are we doing here? We're in the I direction. We have 13.437 minus 0.433 times this. So it's a minus times a minus is a plus. So times that guy, and then plus 8. So minus, okay, so then according to this we get that the acceleration is 29.5 0.12 meters per second squared, and that is in the positive direction. So there you have it. Okay, V sub c is this guy here. A sub c is that guy there. And we have it. So I hope that was helpful. It's a little bit of a long problem, and in general, the problems are, I mean, they're just longer because there's more to calculate. But there you go. I hope that was helpful, and I will see you in the next one.